Hi, hello. Good afternoon, everyone. My name is Kimi Pandey, and I'm from Space India. We are gathered here to interact with an astronomer and also a space system engineer. Let me introduce you to Mr. Kunal Naik, who is at present space system engineer, joining us from Dubai and will be interacting with you guys on why space is important and why astronomy is essential. So, Mr. Kunal Naik did his bachelor in aerospace engineering in Chennai from Hindustan University. During the interesting and engaging 4 years in the university, he was part of multiple international projects like CANSET, USA, and UVA competitions in China. He also represented the university on various national and international platforms. He pursued his master's from International Space University in France. Later, he got opportunity to do apprenticeship in Japan for 4 months to work on prototyping moon projects with Space Robotics Lab. After finishing his master's, he came back to India and started interdisciplinary talks in his career till date. He has visited more than 17 countries. At present, he is working on future moon exploring projects along with European Space Agency and Mana Electrics Dubai. So, now I would like Mr. Kunal, to continue with this introduction.
Hello. Am I audible, guys? I hope I'm audible, right? All right, perfect. Hello, everyone. I hope you guys are all doing well. I will try to share my screen in order to have a good visualization. I guess I'm disabled for screen sharing. I'm not able to share the screen. Is it possible to share the screen, please? I think it's from the admin. Perfect. Thank you. All right. So good afternoon, guys. My name is Kunal. As Ms. Kimi has already mentioned about me, thank you so much for giving me the opportunity. I would thank Space India for letting me to speak to you guys about space, which is very interesting topic and have been interesting topic for me since years. And I am still a student pursuing knowing more each day. Maybe while even interacting with you guys, I'll try to learn something more from you guys, know something interesting. In this I have made a small presentation which will talk why space is so important, why we feel we spend billions of dollars for space, why. So I'll try to answer that questions. I'll also try to talk more about astronomy, a bit about why astronomy is important in our day-to-day life. We all run after astronomy, but we do not know what exactly it helps us in our day-to-day life. Also, some very interesting from my side, quick facts and quick links about some websites, which will be very interesting for you guys to enjoy, to learn, to play games over it. I meant space games. So this all things, cool things we'll be covering, and I think it will be very useful to you. So yeah, let's begin. So introduction is already done by Ms. Kimi, so I do not want to waste time over that. So let's come to the very interesting topic of why space, and is it really important? All right. So I'll I'll start with this saying that we surely know that we are spending a lot of science technology over the space sector, and right now in India it's booming. Like every time we hear in newspaper, we hear about space. Everyone is talking about space and things going to space. And we as a normal, like we as a citizen, we think, it's a waste of time, waste of money, why we are spending a lot of money towards it. I think it's logical, we should not spend money. Yes, I think if you think that way, I think it's right. If right now, if you think we spend billions of dollars, when I say billion, one, just to understand, 1 billion is around 100 crores in INR. But we spend billions of dollars just on some a box of metal, just we send outside for some experiments, and that's it. Why? So we have so many problems on the earth. For example, only in India, if we say, we have multitude of problems like drought in various states of India. We have overpopulation, as we have overtaken China, as we all know. We have poverty, we have child education, we do not have education well, we have deforestation, we have so many problems. We have also have marriage issues. We have, the big actors who are not getting married. It's a global problem. It's India's problem. Then we have the political problems. We have problems everywhere. So I'm just showcasing India's problem, but we have multitude of problems, but still we try to invest in space. Why? NASA spends around, the data which I'm showcasing right now, it's of 2018. Well, right now the budget will be 2 times more than what it is right now for NASA for sure, for ESA for sure. So 19 billion, that means 1900 crores of rupees, INR. So that's a lot. And then 1900 you convert into INR, and it's a big number. So we spend billions of dollars just on few space projects. Why? So there must be some reason. There must be some logic behind it. So number one, I mean, the most important reason, the reason is why in Delhi we feel, we cannot breathe well. It's because of the climate change. We cannot have proper, in winters we have super cold temperatures. In summer we have super hot temperatures. Why? Because of the climate change. And how we know about it? We know about it via satellites. So what I mean to say is climate change is necessary to monitor. We need to know why it is happening, how it can be prevented. So this is one of the reasons where the satellites play a very important role in understanding planet's role, in understanding how the weather change over time, what are the means, how we can control it, who is emitting pollution, so we can properly understand these things. The second is the Earth observation. Of course, you can see in the image right now. See, of course, you will see that it's a 1992 image and then 2012 image. It's an old image. But if you see the 2022 image, you will see there is no ice cap. It's pretty low ice cap. The pink color you see here is from the Earth observation satellite. Of course, it's a animated image. It's not the real image, but here you can visualize that the ice caps has melted from 1992 to 2012. That means the ice cap has melted. That means the water level has risen. So it's higher water levels. Thus, it helps us to understand that, okay, we are creating a lot of problems on the planet Earth and we need to find another planet. So that's how satellites are very useful to understand erosion, deforestation, inland water, how much water is below the earth, below our region, below, for example, in Gujarat, how much is the water level below the land. So this can be also detected via satellites, also via UAVs, but it needs a high precision cameras, of course. The second is the second reason is the most important reason, which is the magic thing. I'll give you like 30 seconds to think what can be this magic thing. I hope, yeah. So that's nothing but internet. So right now we are connected via, oops, sorry. Sorry. Let's see. Come on, don't hang. Okay, again, the magic thing, which is the internet. We all know that we are connected via internet right now. I'm presenting to you guys via internet, and without that, it's not possible. Even our daily life is connected via this. Imagine your life without internet in today's world. It's not possible at all. Just stay without your mobile phones for half an hour. It's very tough nowadays because everything is super connected. Communications, your phones, your banking, your education, everything is now over internet, and it's pretty important. Every day in India, as we say, as we speak, we have more and more requirements towards connectivity. We say that the Geo is not working, the Airtel is not working, okay, this is working super fast. So that means we have more requirement towards the internet. We need to cover more areas towards internet. Other thing is the telecommunication towers. As we see the towers here, these are the ground-based telecom towers, which are over various locations in India. Of course, you can see while you are traveling over roads, you see the long, huge telecom towers which are connected. So these are called the ground-based telecoms. Now imagine if we do not have satellites, how can we connect telecom towers with other countries? So if you want to call international, we have to connect such huge cables via other country. As you can see here in the right hand side, some drawn lines. So that means the connections, they are actually the internet cables right now. At present, we have such internet cables underwater. So imagine if there is an issue in one of the cables, then how are we going to deal with it? Of course, we are spending crores of rupees and billions of dollars over just tackling this issue. And this issue, again, it will be solved via satellites. That's why everyone is trying to send satellites. And excuse me. Yes. Really? Oops. Too early. Okay. Can you see my screen now? All right. So can you see my? Yeah. Can you see the screen now? Or there are gaps in the middle? All right. Okay. All right. So let's do this thing. I'll be very quick again. I will not explain in detail, but of course you have heard enough of it. So maybe I'll go very quick just to showcase the presentation again. So as I said, the science technology space sector is a waste of time. We spend billions of dollars on it. Why? So I said there are many problems on Earth, especially in India, where population, poverty, we have child education problems, we have deforestations, we have terrorism, we have the issue which I said, the marriage issues. It's a hot topic in India. And then we have the political issues, and still we spend lots of billions of dollars for space. So the data, as I said, it's $43.5 billion, which was around 4,300 crores of rupees spent in 2018. I think, again, it's not visible, right? I think there's a technical issue, is it? Is it visible? Oh. All right. So I said about the reason one, which is the climate change. I talked about it. Then I was talking about the other magic thing, which is the internet. This is how we are connected. Unfortunately, it was not connected earlier via shared screen, but now it is. Okay. We were here regarding the telecommunications. So I said about the ground connections, how right now the telecoms are connected. The internet is connected via underground cables through various countries. Of course, we have communication via satellites, but major communication is mostly via telecoms, which is very expensive to manage, because if there is a fault in some areas, we spend billions of dollars just to rectify the issue uh, and investigate and solve the issue. But now we have satellites, which we can solve the issues very easily. We can even have the satellites revolving around the Earth, which can give cool images and also good coverage area over few remote locations. Well, we still have issues in India, of course, and many areas, many locations around the world, but still, that's why many billionaires are trying to solve the issue by sending every month they send thousands, hundreds of satellites, not thousands, hundreds of satellites for telecommunication. So as I said, there are various companies which are Intelsat, OneWeb, SES. So just for an example, you watch TV channels, you watch in cricket, you watch sports. How is this possible? How the broadcasting is possible? It's only possible because there is this company called SES. So it's a telecommunication company. They have their satellites around the Earth. So they provide you the communication, they provide you the telecommunication. So similarly, there are other like Intelsat, OneWeb. By the way, the OneWeb is the company acquired by Bharti Airtel. So the Airtel, we can say one company. Then there is a SpaceX. So everyone wants to cover the whole Earth, like as you see in the photo below, in a very layman language. They want to cover with satellites so that it's a very cheaper and easier to connect with people. Now, the reason number three, which in India sometimes doesn't exist, but if we do not use this reason, then our life would be a bit hectic. In India, we just ask to any panwala or maybe to any rickshawala just to see where is the location, how to go there, how to reach there, is it right or left? But we have GPS. So GPS is only possible via satellites. Without satellites, we have Indian satellites, of course. It's called Navik. But we have local satellites, which are the shopkeepers. We just ask directly to hawkers and shopkeepers like where to go. But in real life, there are satellites. Our journey, our aircrafts, trains, everything is connected via GPS. Even with trains, you think that it's just a normal road, it's a normal rail, but no, everything is super connected, and live tracking is also nowadays it's advanced. Even if you go by the roadways by car, there are industry 4.0 where they want to connect cars directly with the satellites, and this is going to happen soon in the coming years. So which means I mean to say GPS is a pretty important thing for the navigation. In earlier days, when we talk about sailors, when they were sailing in the sea, they used to see astronomical mapping, which was the main reason why GPS was invented. So astronomy was the key at the first place. Because of astronomy, GPS was invented. Because the sailors used to track the location of the stars and they used to sail. Even in villages right now, many people, even in Europe, whether it's USA, whether it's India as well, we used to track sun's location or star's location, and then we used to decide our directions. So what I meant to say is that astronomy was the key to technologically advance all such areas. Another cool thing is the triangulation method, which is of course used by the satellites. I don't want to go in detail, but right now you may have phones, or you must be using your phones. So right now your phones are being triangulated by 3 satellites. That's why you have a precise location. Generally, it's 3 to 4 satellites to have a precise location. So just in your mobile, you have a small chip that is being connected to the satellites. So you are right now, you are also connected via satellites, if in one way, if I say that. Now, the reason number 4, which is quite a dangerous one, it has happened for 5 times with us, and we all should be afraid about it. And that's how I want to proceed in my presentation later, that why it is so dangerous and why it is important. And that's the mass extinction. So the mass extinction has happened 5 times, like major 5 extinctions. So that means the asteroid crash, or it's a meteoroid hitting the planet. So there are many such extinctions which has happened, and it will happen, of course. And that's why we need satellites to track these meteors. Well, poor earlier civilization or the dinosaurs, they did not have such techs to understand that there are such major extinctions that are going to happen. But we can track the meteors, we can track the asteroids coming from far distant away, and we can see that, okay, now this asteroid is on the path to Earth. So at least we can track it down even millions of kilometers away or light years away. We can track that the comet is coming, and that is done by satellites, which is the deep space networks, which I'll try to explain of one of the huge space telescope. I'll talk about it in the coming slides. But just to give you the gravity of the situation, that deep space network is pretty important for us to understand the mass extinction. Without this, without the satellites, we are doomed. So it's just like you are in a dark room without anyone, without mobile phone. So it's like this. Without satellites, the scenario will be such. If you see on a huge planet like think in a planet like situation, and if you are an atom, so in that case you are just in a dark room with no hope and no light. So after looking at this, I may think that space is literally not the worst thing, but maybe one of the best investment. Maybe you can think on it. There can be other reasons as well. I may have missed it. Of course, there are other reasons. If I want to speak, there will be a lot, but I do not want to speak and spend more time on it. But this give a thought after the presentation, and give a thought about it, like what you think, the space, how you are connected to space. Think about it, and then talk to your colleagues, talk to your parents about it. So as I said about the deep space networks, and I said about the huge telescope right now we have in space, you must have heard a lot about JWST, which is the James Webb Space Telescope. Of course, it is connected to astronomy. It's a huge telescope, and I wanted to speak to you most probably on this one. All right. So as I speak, it is right now revolving around the sun, and it is a huge space telescope ever built in, and it was envisioned in 1996, which means it took 2 decades, that is 20 years, to just develop this huge telescope. The fun fact of it is it's like a school bus. It's kind of a school bus size. But the other thing is, when it was wrapped inside a rocket, it was just a size of a small van. So how incredible engineering, you can see that it deploys in space, and it becomes like a huge bus. Here you can see, you must have heard a lot about it via different mediums, via Instagrams, social medias, articles about such telescopes. But what is something interesting about it? Why everyone was talking about it? So it is because it is one of the huge and designed differently than the Hubble Space Telescope. So there was the last telescope which was huge. It was the Hubble Space Telescope, and this one, the James Webb Space Telescope, is one of the bigger, the biggest and the huge telescope, which has varied set of scientific goals, including examining nearby exoplanets, studying nearest stars, earlier stars, observing supermassive black holes, and looking for signs of cold dark matter. So it is also used to study young galaxies, to answer questions of how galaxies assemble, how is there any water there, what are the clouds there, clouds of dust, to watch this formation of the stars, the death of the stars. And this is all possible via the instruments, the science instruments, which is used in astronomy. So it is designed to look even further back to the edge of the observable universe. So when we go back in time, the light from the objects in the distant part of the universe, the satellite covers it. Then if you see in the image, you see this gold plated, some gold color plates. Actually, they are the primary mirrors, and these mirrors have the coating of gold. It's a 24 karat gold, and it reflects red light in a better way. So red light in astronomy, it's pretty interesting and pretty important, because objects light become heavily shifted towards the red side in the electromagnetic spectrum. That's why gold plate is very essential in order to reflect light. Then interesting fact is the golf size amount of gold. So if you have seen the golf ball, the amount of the gold has been used of that quantity. So it's pretty expensive. That's why you can see that why it is super expensive. Other interesting thing is it's 1 million miles away, which is super far from the Earth, and four times away from the Earth. So other interesting thing is there is no service and repair operations which can be done on this satellite, because it's super far. We cannot reach to this satellite. As I said, it can detect water on the exoplanets. So this is pretty interesting, because wherever there is water, there will be life. So for us, it's very important to detect water over these exoplanets. Then, as I said also about this, to spot the first light from the stars in the universe, then I also said about this folded origami. So it's a Japanese way to say origami, means a folded, like in an easy way, if I say, it's like a folded handkerchief. All right. So imagine that what I'm right now doing is like the like fold paper, and then you try to fold it and try to put it in the aircraft, and then in the rocket, and then once it is in the space, it unrolls and deploys automatically. So that's an origami in a simple way. Other interesting fact is one side of the telescope, it's 85 degrees Celsius, around 85 degrees Celsius, but the other side, it ranges to minus 200 degrees Celsius, which is super cold. So one side will be hot and the other side will be super cold. So it will be a bit of difficulty in terms of engineering as well. So we can say that James Webb Space Telescope is like a state of art in one way. And it will help us to locate new planets, accurately identify the presence of important things like water. It will also help us to find, carbon, nitrogen over different planets. So in one way, this is like a just huge, incredible thing which is right now in space. And it took 2 decades, as I said, 20 years to just build this thing. Now you must also have seen such images. So what are these images? As you see on your screen, they are the Southern Ring Nebula. So the brown and the orange, the bluish thing, you can see that just a shell of gas and dust ejected from a dying star. So earlier we also had such images, but from the Hubble Space Telescope. There is a difference between a Hubble Space Telescope and the James Webb Telescope. Back in the 10 years ago, Hubble was the most huge space telescope ever built. But now we have more powerful than Hubble and can have the infrared, more scientific, strong instruments on board on the James Webb telescope. and thus we can see clearly what are the planets, are there any exoplanets, are there any galaxies, are there any nebulas, are there any asteroids. So JSWT has already sent us few images. On the screen, you see the Southern Ring Nebula, the comparison of the Carina Nebula. So this is the Carina Nebula. So by James Webb Telescope, the earlier telescope on the left-hand side, which has written visible, you can see the Hubble telescope has shown us such image, while the same image has been compared with the JSWT, the James Webb Telescope, and you can see clearly there are many various galaxies. The one shining here, you see, they are nothing but they're galaxies. They're different galaxies. For example, we have Milky Way, right? And our next galaxy is Andromeda galaxy. Similarly, we have another. You see here the tiny bright spots. They are galaxies. So just imagine how many galaxies you can just see clearly. And inside galaxies, there will be another millions of stars. So just imagine and think that we are just on a small, tiny pea in our universe, in our galaxy. What about this galaxy? Do you think there will be another species like us talking about such or talking something similar to someone else? And what kind of species will be this? So for us, we are such curious, the humans are such curious people. And that's why we try to go in deep about such topics, and we try to go deep in astronomy, in making such science experiments to understand if there any life there. So also another good thing which I think it's important to know is the oldest galaxies which detected by James Webb, which is around 300 million years ago. So as you know that the light travels very fast. But imagine that this galaxy, when it was formed, it formed with a boom. And this boom has been recorded now by James Webb Telescope. So imagine that this galaxy must be how many millions of light years away. It's damn further, the furthest thing. So what it means that we can we can go back and check out further galaxies, and even what happened during the Big Bang, what happened during the origins. So James Webb Telescope is like a boon in terms of astronomy and for the astronomers. Other cool thing I wanted to show you, I'm not sure if the link will work. Maybe if I can share my screen here. Just a question, if anyone can answer, is my screen visible? All right, perfect. So here I wanted to show you, it's a very cool website. I just wanted to show you the difference. The left-hand side, you can see, is the Hubble observation in 2007. But now on the right-hand side, you see there is the image of James Webb Telescope. So now you see the clear difference. This is the James Webb Telescope, and this is the Hubble Telescope. You see the clear difference that look at the stars in the center. You can see that not the stars, they are galaxies actually. And look, you can clearly see the difference. Also, you can see below the brown, we can say it's a shell dust, is the cosmic dust. Even with the James Webb Telescope, you can literally see beyond these clouds. Let's check some other photos. Even you guys can visit this website. It's a pretty cool interactive website where you can check 2 different photos. All right. All right. So now, a very important thing, I'm sure you guys must be aware that, not sure if you are aware, but let's see if you guys know about it. So how astronomy helps, or how astronomy has helped us in our day-to-day life. So the first thing is we cannot live without phones. So that means that, of course, the phones are becoming smaller and smaller because of the chips, because of the CCDs when I say CCD, they are not the cafe coffee day. It's charged coupled devices. So they are the small integrated circuits with the charged coupled devices, which are inside our mobiles, which helps us, which are integrated within our mobile phones, where we can take high resolution photos. And this was only possible because way back in 1976, such small sensors were created for astronomy. So astronomy has pushed, and technology, we have transferred the technology towards mobile phones. Then with the GPS, as I said about the sailors use astronomical, even till date, when the ships do not have, in one of the locations in the sea, they do not have GPS, they go the old way, which is tracking the stars. Thus, thus GPS came from tracking of the stars. Thus, astronomy is like a technology, has given a technology transfer and a push to a normal life. Then I already said about the mobile phone cameras. You are using the high resolution cameras, and that's only because of the push given to astronomy. Then you have imagined the comfortable bed, the foam bed. This was invented actually for astronomical satellites, but now they are used for other reasons. But you must be interacting with it every day, or you must be using it every day, but you do not know that this were first foam material was used for space things. Then about the climate study, as I already said to you. Then the military and law enforcement, of course, we need to protect our space, we need to protect our region, our territory, and for that earth observation is pretty important, and thus the telescope comes in role. So imagine that right now we have telescopes pointing towards the sun, but what happens if we have the telescope pointing towards the earth? So that means we have a very clear high resolution image of the locations of the borders, location of our houses. It's like a surveillance. So even this is happening. We do have surveillance spy satellites revolving around the earth, checking, taking information of other countries, of other mischievous activities, pirates, many things. Other very important thing which you should know is the health. So in the health sector, even the MRI scanners, they are all possible because of the CCD devices, because of the X-ray technological push, which was given because of the astronomy. The first X-ray was used for astronomy. So it's like the low energy X-ray scanner, which was developed by NASA in 90s, maybe 80s, I should say. And it's currently used for the outpatient surgery, sports injury, or various things. So if you are imagining what is MRI scanner, it's like the MRI scanner, as you can see on my screen. It's a huge MRI scanner you can see. Well, certainly it was meant and it was made for astronomy. And then we converted it into MRI, which can be also used for medical purposes. Also, radio astronomers have developed a method for non-invasive way to detect tumors. So even the tumors inside your body, that can be detected because we have made an advancement in the radio astronomy. So there are many, like combining various methods all together. You can even detect like a true positive detection rate has been said that 96% has been detected, like the breast cancer patients has been detected via such methods. So all thanks to the radio astronomy. Because of the radio astronomy, the push is more towards other sectors as well. And I also said about the potential threat from space, which is why we need the deep space telescopes in order to see if there is a huge asteroid coming back to Earth. Then we have the airport X-rays. Many of you must have gone to airports or railway stations where they check our bag or luggages. So what are these machines? Actually, these machines have the X-rays in it, and this X-ray machines were made for space and for astronomy. Then there is another, I'm not sure if you must have seen this gas chromatograph. So that means on airports, they do have such machines, they do check and detect some drugs or chemicals, intoxic chemicals or toxic chemicals. Um, Even the police, they use such chromatographs, and these gas chromatographs were first used for astronomy. So that's what the astronomy in our day-to-day life, it's impacting every day, but we weren't aware that it impacts us in such. There are other applications as well. Well, I'm not covering most of the applications. Of course, I'm just covering some important day-to-day life applications. But in general, I would say that astronomy is a very formal scientific way to search and ask for questions: who, where, why, which, how, and what. So even by this age, I am very curious, and I try to search over internet over many few questions, few answers, and I try to search via various disciplines. So when I talk about space, I tell you that space is not only for engineers. It's not meant for engineers, it's meant for all disciplines. So for example, you know that space is diverse, like it's huge, interdisciplinary, diverse. It has space engineering, it has space medicine, it has space applications, humanities, space business, space law and policy. It's a very diverse field. From far we see that it's only engineering, must be engineers, must be going to space. Well, it's partly right, but it's false. Anyone can join in space because it's interdiscipline. Any sector is connected to space in today's 21st century. Everything is connected to space. Literally, you just name it, and I'll tell you that okay, this is connected to space. And or if not, then I'll tell you that how it can be connected to space and how it will be useful. So I would like to share something, another cool thing which I would like to show you. It's a very cool website and a learning arena for you guys where in your free time or while during you guys study, if you are a space enthusiast and or astrology astronomy enthusiast or astrobiology or into games or into YouTubes, I'm going to showcase you the best websites which I have been looking around, and I'm working on these websites as well as a in a part-time projects. I try to learn more from these websites. Let's go one by one. So Zooniverse, maybe if you guys can make a note, Zooniverse is the world's largest, most popular platform. It's like the volunteer research. Anyone can be a researcher. Anyone can make a discovery. They can write papers together, and it's a huge thing. I'll go to this website and I'll showcase you that. So here it contains all disciplines. Anyone from irrespective of any discipline can join, or any age can join. For now, I have clicked space, and right now you can see that there are so many science citizen projects where you can enroll yourself for free, and you can work with all the people around the world in one of your free time. So maybe if this is your hobby, if you think that space is your hobby, you can just go and check out this cool website. Then the second is if you are interested in astrobiology courses, there is this NASA astrobiology course, which is here. It's generally, they are free courses. See, origins of life. So in your free time, if you are curious about such topics, please, I would say internet, as because the satellites, we have free lectures and everything is free. The problem is we are not using anything. There's so much of data available over internet for free, and we don't use it. Another thing is another citizen science project by Sky and Telescope. You do not need any degree, you do not need anything, you just need your PC, your laptop, and that's it. So you can even make a note of this website. It's Sky and Telescope, the essential guide to astronomy. It's a citizen science project where you can collaborate with all people around. Some are researchers, some are astronomers, some are students. I think it's a huge place where you can learn and you can even help science to go further. Then, very interesting, and I love this thing, is the SpaceX docking simulator. So this, it's like a game. I love playing games, and You must have known about SpaceX. It's a very famous private company, and they used to launch satellites, and even they used to launch astronauts to space, ISS, International Space Station. So apparently, they have made a space game. So as you can see on the screen, it's like a simulator, and it's like you have to dock. You have to dock in the ISS, International Space Station. And trust me, I have played so many times. It's my favorite pastime. And literally, it makes you feel as if you are an astronaut and as if you are docking to the International Space Station. It gives you very cool graphics. And yeah, I think you guys should play this game. It's pretty interesting. Then the second one is the Kerbal Space Program. Here, this is also a very interesting computer game in which you can create your own space rockets and then you launch them. Maybe you can check out the YouTube videos of them, but it's a very interesting space program. So imagine that you create and manage your own space program. You build your own spacecraft by just putting different engines. Imagine you have different engines, rocket engines, you mix them, you make a rocket, you calculate the amount of thrust you require to push your rockets, and you fly them, which is very important, I think, to understand, to know. So you guys should also go through this website. It's called Kerbal Space Program. Another YouTube space channel which I love is this Kurzgesagt, and it's one of the best space channel, I should say, because they explain you everything in a very graphical and a very layman language, which anyone can understand. And I think this will be really important for you guys and very nice to you guys. I think you guys will enjoy this. And the third is the Google Earth. It's the Earth observation where you can see, anything. This is a very cool thing by Google. Of course, there are other platforms as well, but I'll try to, show you a bit of Earth observation data. That means the satellites right now revolving around the Earth, they send this data and they compile all the data together, and then it gives you is this. So now name a place, and these guys will show you. So let's go and search for example, time lapse in Google Earth. Let's try the time lapse. Well, you need a good internet for sure. It will take a bit time, but it will at least showcase you. Well, my internet is slow. I don't want to waste more time, so I'll try to okay, it's showing. Okay, so we are in Cambodia right now, and it will give you how the vegetation looked in 1996 and how it looks right now. So let's go and do with Dubai. I guess Dubai is a pretty interesting area to see. Because in 90s, Dubai had nothing. It was just a simple land. We do not had even Palm Jebel Ali, then the Jumeirah Islands. But then, okay, let's go with the time lapse. Whoop. Yeah. Okay, so I'm not sure if they have given here, but maybe I'm puzzled. There is a way in order to get a proper time lapse in which you can see how it looked like in 1990s or 2000, how Dubai was looking from the top and how it looks right now. So there was a huge difference between such measure distance, next time projects. Okay, forget. No, let's go just with the normal thing. So right now we are going to see the Louvre. It's in Paris. So why I want to showcase you is this, that because of the satellites, we have pretty cool images where we can go and explore and have fun with such softwares. I guess in your free time, you guys should go through such. You can even zoom in and see how beautiful it looks. And this is just because of the satellites, just because of the Earth observation data. So I let you guys to use such softwares and yeah, have fun with such softwares. It's pretty interesting. Then the other one is the Star Walk mobile app. So this mobile app, I have not linked it because it's you can find it easily on Apple or Android phones. It's just a very easy way to track satellites and track planets and constellations. You just have to move your phone above and you just have to rotate it around and you see the real images of planets. You can see the real satellite orbiting around, live locations, and it's a cool way to detect planets and satellites. Well, I guess that's it. I would say for now. Do not, I don't want to bore you guys more. So that's it. I would say, if you guys have any questions, please do ask some questions. I'll be very happy to answer them. If you want to connect, please connect via my email. If you have any questions, I'll be very happy to connect and very happy to talk to you guys. If you are more into social media, you can find me on Instagram called Spacebot. I guess that's pretty much. So I open the floor for anyone. If anyone has some questions, not only in astronomy, but also if you have any questions regarding space or space systems or what I work right now, about moon projects or about moon, anything, I will be very happy to answer them. Thank you so much.
Thank you so much, Mr. Kunal. Thank you so much for giving such an informative interaction to all our audience. Thank you so much. So now we are going to have a question and answer round. Okay. So it's a request to all the students, those who have joined, to put your questions either in the Google form or in the chat box. Try to keep the questions relevant to the topic. So let's just start with the question and answer round. Okay, so our first question is from Dikshish Mishra, Army Public School, Class 7D. The question is, what is dark matter?
Wow, it's a huge question. Probably what we know right now, whatever all the astronomers know right now, is also theoretical, and also no one knows, to be honest. No one has a right answer. So whatever we read right now over internet is the a kind of a energy which we cannot feel, which we do not know. So whatever right now, I'll be very frank with you. Whatever we know right now, whatever everyone tries to say, that there is this anomaly happening in space, and then they will name it as dark energy. They'll name it as dark matter because of dark energy. So to be honest, no one knows what exactly is such things in reality. Theoretically, it's just a solution to say that there is this anomaly and it's an energy which is trying to balance with other energies, but in reality we do not know because we do not have any such potential proof towards it.
Okay, sure. So should I move to the next question? So the next question is from Vidushi Verma. So the question is, why there is no gravity in the space?
No, why there is no gravity in space? Okay. So it's a good question. So All right, let's take it. Give me a minute. Let me check if I have some illustrative thing in my. Hmm. Okay, so let's imagine that this is Earth. All right, and any satellite is revolving around the Earth. Why the satellite is revolving around the Earth? Actually, it's revolving because the satellites are constantly falling towards the Earth. Now, in space, in space, it's a void. Void means there is no atmosphere, of course. There is no such thing as air. It's completely vacuum. And why it is? Because there is no such element. There is no such the words I say. For example, Earth, on the planet, we have an atmosphere because it's concentrated. The planet is a concentrated in a round, like a round planet, and then we have life. We have plants. We have vegetation. We have, because of such, we have atmosphere as well. And because of atmosphere, we can breathe as well. For example, on the moon, there is no atmosphere. There is no gravity. Gravity is nothing but it's like a pulling force towards the Earth. But in space, there is no such pulling force. There will be such forces acting towards the planets. So if there is a huge planet somewhere, for example, Jupiter has one of the highest gravity. It's a pull towards these planets. If you are close to Jupiter, of course, you will be pulled towards the Jupiter. Or, for example, imagine like a fabric. There is a huge fabric. Okay, this is a good example. Okay, so imagine that this is a fabric, and this fabric, you put a huge a ball, like a marble, in the center. So in space, you have to imagine things because it's not physically, known. So imagine it's a huge fiber fabric, and on the center you put a marble. Marble has some weight, so the fabric will be pushed down. So it will create a dent. So it will create something like a slope, and because of the slope, you imagine that that's kind of a gravity, that's kind of a force, that kind of a force which helps the planets to revolve around the sun. In a normal way, if you want to experiment, do this thing with your four friends. Take a huge take a bed sheet from the four ends. Everyone holds the bed sheet. In the center, you put a basketball, and which implicates like a sun. The basketball is like a sun, and then take a tennis ball and try to rotate it. Try to spin like a round around. It will What you will see is the tennis ball or the smaller ball will try to revolve around, and then it will try to go near to the sun, near to the basketball, or near to the football, or near to the bigger ball. So that means in reality, now we talk about space. In reality, that means that this is the pool in real life which helps the sun, which helps the earth to revolve around the sun. In your question is like why there is no gravity in space. There is gravity in space, but the gravity is related, is a kind of a, in a easy word I would say, is connected towards the planets. So for example, if there is a huge planet, gravity will be there because of the planet. So nearby objects will be constrained because of that planet's gravity. But if there are no planets, there is no gravity anywhere. If there are no planets, if there are no huge objects, so any object in space fabric, there will be gravity around that object and on that object. But other than that, it's a combination of all other gravities, which is very minor. So in general, theoretically, there is no such gravity around. The gravity is just because of the different planets.
So, sir, we're going to go with the next question. So, the
Yeah.
next question is from Ujjwal Gupta, the Maurya School. Standard is 50. So, the question is there any asteroid coming towards the Earth?
Very good question.
And,
Actually,
and
um,
if it is coming, where it will be crash on? Will it be crash on Earth?
that's why it's a very good question. Thank you. So, yes, that's why I said in my presentation we need satellites. We need deep space satellites where we can track. So imagine again that this is Earth, and I need another asteroid. Okay, asteroid is here. So this is another asteroid which is coming from far galaxy, from other galaxy, and it is heading towards Earth. So how do we know and how do we track where it's going to hit? So that's why we have satellites. So this is a satellite, imagine, and these satellites are going to track the movements and going to track the distance. As you know, in space, any object travels in the same path, which is Newton's law, which is F equal to ma, which is the force is equal to mass times acceleration, and also to the first law, which means that any object in space pushed in one direction will move in one direction unless and until some other force applies on it, which means that if the asteroid is coming towards the Earth, we will be able to predict from where it is coming and where it will be hitting. For now, no, there is no such asteroid. Please do not watch any news channels. We in India, we have many news channels telling that, okay, this is the world is going to end. There will be a huge asteroid coming towards us. There is no such thing. Of course, we have satellites and we have huge, good satellites to take care of it. So there is no such asteroid incoming. But if there is any, we will be knowing from for next 1,000 years. So we will, because of the satellites, we will be able to know its precise location and remote locations from where it is coming and where it is going to hit.
Okay, sir. Now we are moving to the next question. So the question is from Anshika Sharma, Indrapuram Public School, standard is 7th. So the question is, sir, I want to become an astronomical entrepreneur and want to become a businesswoman running astronomical businesses, but I'm still confused. What steps to be taken?
Right. Can you repeat the first name?
Yeah, sure. I'll repeat once again. Sir, I want to become an
No,
astronomical entrepreneur.
I understood the question. I wanted to know the name of the person.
Okay, the name of the student is, just a minute, it's Anshika Sharma from
Yes.
Indrapuram Public School, and it's from 7th standard.
Right. Okay.
Yeah.
So I would say that thank you for asking this question. I guess it gives me a big smile, of course, to know that someone wants to do such thing and become an entrepreneur in space. Um, I can explain or tell you how it is possible. It's a big thing, and very glad to know about it. Thank you for asking that question. So, as you know, as we all know, that space is booming right now, and we all know that space we have so many opportunities, and how we can go and towards the space business. So right now, as we speak, you are finishing your high school, your schooling, then you finish your high schooling. So of course, this is the time where you can explore different areas of space. Even till date, if I speak right now, for me, I was more into astronomy earlier, but then when I started to study further, I came to know more subjects about space. So what I meant to say to you is, it's about exploring. So at this age, and at this time, the best thing right now is to explore different websites. I have showed you many websites, and there are websites where you can do a research-based astronomy, where you can meet other people around the world. You can discuss your ideas. I would suggest to try various courses, learn about astronomy, learn various things about astronomy, see where you're comfortable at, then further go for your bachelor's. Again, if you want to start a business in space, you do not require any degree, to be honest. You do not require any space-based knowledge or a degree. You just require, of course, the space-based knowledge is important, but you do not require any degree to start a business. You need to learn. You need to explore yourself in this field. You need to learn more, and then you can once you have the idea and you see that it's a huge niche in the market, that astronomy is going to serve this purpose, and you are going to solve this problem, you can start with this business. But before starting a business, I want you to, what the best thing is to explore different topics of space, get some new ideas, write down all your ideas and try to implement, talk with the people whom you like to talk about space, explore ideas, work together, and then you will come up with good ideas of making a project. So for now, I would say just explore the different courses, know more about space till your bachelor's, and after your bachelor's, start with the business. And of course, you can connect me anytime on email, and I'll try to, if you have any such questions regarding such, I'll be happy to answer.
Okay, thank you so much. So for the next question is from Vivan Saxena, Pacific World School. The grade is 4. So the question is, have you found life on other planets?
I don't know how to answer this question, but if someone has found it, if the agencies have found it, let's be honest, there are agencies who are working towards this, which is NASA, which is ESA, which is, I'm not sure about ISRO. Even ISRO must be working towards it. But for now, there is no such data which can showcase that there is a life form on other planets. But we have found traces of water, traces of carbon over different planets. That means traces of water and traces of carbon says that there will be life form now. I mean, in the future or in the past, there will be a life form, or there must be a life form. But presently, we do not see any life form, moving, or like aliens or something. Very physical evidence. There is no such physical evidence in terms of detection over other planets. But sure, they have found water on exoplanets, and again, water means life. That means wherever there is water and carbon atoms, there will be life. So that's the reason we need satellites far enough to know more about life forms.
Okay. So the next question is, it's from Kushagra Arya, JSS Public School. The grade is 6th. The question is, are Milky Way and Andromeda Galaxy gonna merge?
Good question. Again,
Should I repeat the question?
There are evidences of galaxies. Some galaxies are going away from each other. Some galaxies are combining towards each other. But this process, it's like a billion years. So no one will ever know what happened, and no one will ever live to understand what happened. To be honest, today we all are living a life. If we see in a big astronomical celestial thinking process, we see that we are all living in a, if there is no sun, we are done. So if the sun dies, there is no life. So anything can happen anytime, I would say. I'm not scaring you guys, but it's just like it will not happen in the next billion years. So we do not have a substantial proof to say that everything is merging or going. We do have some proof showcasing that the galaxies are moving or going separately towards different objects, but that doesn't mean that they will merge. So for Andromeda and Milky Way, maybe in billion years, possible. No one will be there to correct me or wrong me. So
Okay, the next question is from Ayan Shukla, Rayan International School, grade is 4th. The question is, Is time travel possible?
No. So with the current physics, we have, the current physics we know, time travel, it's not possible, because you have to travel at the speed of light. So for example, it's a very good question. I guess I'm very interested in answering this question. So let's answer it via this. All right. So imagine this is Earth, or this is one object. All right. And the light is passing. So whatever you are like you are doing some actions, that actions, someone is watching your actions, and that person is, imagine, 100 billion miles away. So your light, the action, your visibility, the light takes time to travel to that distance. And you know that the light travels the fastest. So either you have to travel at the speed of light or more than the speed of light, which is not possible and relevant with the physics right now. But maybe in future, who knows, if there is a time traveler who comes back from the future to the past, which I do not see a point, and which I do not see that there would such exist. But just in science fiction movies, I say, I doubt if there is anything such happening right now, for sure. And there is no such, because it does not governs the physics, or the laws of physics.
So the next question is from Disha Gupta. Prudence, grade is fifth. What is black dwarf?
Sorry,
What is black dwarf?
what is black dwarf?
Yes.
Wow. Okay. Even I'm not aware of this question. Let me search. What is black dwarf? So it just represents. Okay. So it's just like the white dwarf star, or the white dwarf planet, or a star, which is exhausted out of its core value, and like the core heating element. But this is all theoretical again. There is no substantial proof if there is a black dwarf. It's just a theoretical saying, I see. This is also a new term for me. I have never learned about this term, but thank you for telling me. Maybe I'll search on this.
Okay. So next question is from Chitangra. The Mayur School. The grade is fourth. And the question is there a mission to Mercury?
There is already mission to Mercury. ESA, European Space Agency, has this mission called BEPI Colombo. So this mission has already been sent, and it's on the way, just to understand the planetology of Mercury.
Okay. So now
I
we
see
have a
there is
next
a lots
question.
of questions about NASA, about how to join NASA. I just want to give you a bit, if you allow me. Yeah.
Sure, sir.
All
Yeah.
right. So regarding this question about how can I join NASA, uh, please, very humbly and kindly, I will say that it's not possible. Either you have to be a US citizen, or either you have to marry someone with a green card. Then it is possible to be an astronaut, or to be in any agencies. Either it's European Space Agency or it's NASA. There is no such thing you can join. Sorry to break your dreams, or if there is anything, I'm not breaking it. I'm just clearing it. Maybe in future you can work towards it. Um, for internationals to work in USA for space projects, or for NASA, it's not possible. It is possible for some science projects or citizen science projects, but to work on such space NASA projects, no, it's not possible. So if you want to be an astronaut, you should try for ISRO. You should try, because ISRO also is trying for human space flight missions, which are incoming. And in the future, as we see, there is a huge potential for space astronauts, or spacemen, or spacewomen. So instead of going to NASA, you should be very happy to join ISRO, because they're also doing very good in space. So overall, my answer to the question of how can I join NASA, I would say please try ISRO. Don't join NASA. There is no point. For me, if you ask me then why I am working for other companies, actually I'm not working for other agencies. I'm working with the agencies, not for the agencies, um, along with their projects. So yes, so it's not possible to join NASA if you are an international citizen. Either you have to get married or either you have to have a green card to join NASA.
So let's go with another question. The question is from Shania Arora, Salwan Public School, and the grade is fifth. The question is, what is inside in a black hole?
I would say a black color because no one knows what's inside the. If I talk about Interstellar, it's all about memories, but um, science fiction, of course, no one knows. No one really knows what exactly is inside black hole or what happens when anything travels or go through the black hole, because we have it's first of all it's not nearby so that we can try. It's millions of light years away. At first we do know that there are black holes because there are evidences which confirms that there are black holes, but no one knows what happens with the black hole. I would say some says that it goes to another, like imagine that this is a okay, so imagine that this side is a black hole here, it's a gap, and then in that other side you have another galaxy. So it's more like, hypothetically we say that it's a gateway to another galaxy or a gateway to another dimension or gateway to another, but no one knows what happens after that. Even the light cannot pass because it has a huge gravity, because everything condenses super dense. So I would say it's black. In one way, black hole is black.
Okay. So the next question is from G. Kritik from St. Gregorius of class 6. The question is, can a star turn into a planet? And another part of the question is, how and when will the universe end?
Okay, can a star will be a planet? Yes, it can be. I do not see any other reason why it cannot be, but it has to follow some Kepler laws. There are some laws in order to identify or distinguish a planet. There are a few laws which has to be followed. In theoretically, yes, it is possible a star can be a planet. In that means, what is a star? What is the shape of the star? If you say it's not the star you see in the sky like a star shape, it's a circle, like a sun. Our sun is a star. So imagine that there is a huge core inside our planet Earth. It's a circle, and it's a like a energy ball, right? And outside there is a huge crust of dust, dust and metals around surrounded to it. So in theoretically it is possible, but practically I do not see any such thing happening for stars converting into planets. No, it cannot convert into planets. What was the other question, please?
Okay, the another question was, just a minute. Yeah. Yeah. How and when will the universe end?
How and
And
well,
when
okay.
will the universe
I
end?
don't know if I give you a philosophical answer or if I give you a it can end right now as well. You just need to switch off the sun's power, and in 8 minutes, everyone will be off. You will never know. So there is no end of universe, I would say. anywhere there will be a point where a life exists. um, so it's like a circle. So an end of life is giving a birth to a new one. So again, it's a philosophical, as I said. So you die to born again. So it's more like this, like a kind of a Hindu Vedic thing, that it's a circle, and it is a circle. So a death of a star, which condenses and then creates a boom. That boom is nothing like a big bang. It's like a big bang. So that death creates a new stars and creates new form of life. So it's an endless cycle. Please don't ask me how to escape from this cycle. I do not know how to escape from this cycle.
Okay. Okay. Kunal sir, my next question to you is, what inspired you to be an astronomer?
Oh, okay. Okay. So first is, now I'm more of a space systems engineer. I work on engineering projects. I work on the moon projects. So upcoming the future moon projects. So we try to deploy rovers. We try to deploy some solar panels over the moon. We try to help other agencies. So I'm more kind of a space robotics in, for the moon projects. But previously, I was a bit of astronomer, and I tried to learn more about astronomy and about every time about space physics, astrophysics, astrobiology via the websites which I already showed you. But what made me to glue to it? It's from the start I was more interested towards astronomy, because watching and looking at the stars, it made me think how, why, and what. So it was like all these three questions which revolved around my mind. And this comes again to this question that I explored further, again and again during my bachelor's. I explored different areas of space, and then I found my comfort zone, which was space robotics, and my interest inclined more towards space robotics, which helped me to learn and do things the job. So I would say the joy of working towards some field. Um, so when you experience such joy in working towards, like a, when it comes to like a play, like you are playing cricket or you are playing, free time. So that joy of working, that if you find that, you know that okay, this is my place and this is what I want to do. So that particular moment helped me to understand that okay, space is more certain space subject is more inclined towards me, and I want to learn more about this subject. So you are an astronomer or a space engineer forever. So it's more like this: you are an astronomer forever because you are watching and looking at the stars for every day. So everyone is, one way is an astronomer.
Okay, thank you so much. And my last question to you is, how do you think the youth can participate more in astronomy?
Wow. So, all right. So that was, thank you for asking this question, because the main point of the presentation is to understand why space is important and why astronomy helps us in day-to-day life, right? So that's the reason I showcase you that how, because of the astronomy, we are pushing our technology towards other fields, other sectors. So coming to your questions, for now at this timeline, what everyone can do is, I have already showcased some websites. These websites will be really interesting and important for everyone, for all the students to go through them, participate in the science citizen projects, to learn about it, to interact, to connect with the people around, talk more about such topics, and then try to form ideas between the group and propose a new project. So there is this section in the science, in the website, where you can create your own projects. So if you are a team of people, you discuss your ideas, you make your own projects, you search for new courses, and then I would say that is the one of the way you can push towards astronomy or push more towards such education or such space education in one way to motivate them to help others learn. I hope I have given proper answer towards it.
Thank you so much, Mr. Kunal, sir. Thank you so much for joining. It was a pleasure to hear you, and it was an excellent and motivating interaction, and we learned a lot from you. Thank you so much, sir. Thank you
Thank
so much
you.
for all the informative answers you have given to our audiences. Thank you so much. And thank you so much to all the audience to interact with us.
Right. Thank you so much, everyone. Thank you for giving me this opportunity. And if there are any questions, as a space enthusiast, I'm pretty happy to answer your questions. Not right now, of course, but you can email me or you can find me over Instagram. We can connect, of course, and let's try to solve your questions then. All right. So have a nice day and have a nice weekend. Thank you, guys.
Have a nice day to you, sir. Thank you so much. Thank you so much, everyone. Thank you so much, Kunal, sir.
Thank you.